So today, according to our course outline, we are to go through subqueries. So since we have some of us that are actually conversant with SQL, I would like to know what would you say subqueries are in your knowledge with SQL? Okay. Anela, do you have anything to say about that? How would
No,
you
no, no,
describe
I don't.
subqueries?
No, I kind of intake right
All
now.
right. So
I'm s-
subqueries is a query that is written inside another query, right?
Yeah, yeah, that is basically it. Well done. So that was a great one. So basically, that's what subqueries are. And that's why sometimes we call them nested queries. So they are basically queries that are embedded within another SQL query. So it could be in the select statements or from or where or having or join. So these queries can be written in any of these statements, but writing them in any of those statements, it depends on our objective. Okay, so our objective will determine where we are going to write that code. So why do we write subqueries? We write them to enable retrieval of data from one or more tables. So we can use them as alternatives to joins. We can also use them as alternatives to functions. So those are some of the reasons why we use subqueries. And subqueries to be used with caution because it is more difficult to read and may perform lower than the alternatives. Remember, the alternatives here could be to join the tables or to use functions. So subqueries may perform lower than these alternatives. And especially when these queries are now having several, they are now nested in, by several levels. So you have several levels of nested queries. It can be difficult to read. So like I mentioned yesterday, when we are writing our SQL queries or any code at all, we want it to be readable because most times um, data analysts or data scientists don't work in isolation. They work with other members of the data team or tech team. So you need them to be able to easily read and understand your code. All right. Then the last point is that in nested queries, so that is the order in which SQL executes such queries. So now let's talk about when you write subqueries in the where or having clause. What is the aim of writing subqueries in these clauses? The aim is to enable advanced filtering. So we have an example here. For example, let's say we have a table, order item, that contains the product and the revenue that the product generates for a particular business. All right. So we now want to filter out products that generated above the average revenue. So normally, this is what will come to mind to do. I select product and I also want to see its revenue from the order item table. So my where clause is revenue should be greater than average revenue. So however, this average revenue is a function that needs to be calculated. And we know that our functions can only be calculated in the select statement. So since we just need the average revenue to compare, then we can write a subquery to replace this average revenue. And this is the subquery. The query, select, then we apply the function average on revenue from the other item. So this will just give us this. Remember, this is an aggregate function, so it's going to give us a specific value, which can now be compared with the revenues for each product in the where clause. So you see, this is the kind of advanced filtering. So when do we now use having? So we use having if what we need to compare with this average revenue is also a function too. Okay, so we want to use a function to compare this subquery. Then you use having instead of where. So what we want to take note of is that it's good to note that when you write subqueries under the where clause, there is no need to alias of subquery. It's not necessary because you just need it for filtering. You're not referring to it. So next is subqueries in the select statement. Now, subqueries in select always returns a scalar value. So yesterday I explained what a scalar function does. It's different to an aggregate function. So while an aggregate function gives you a column-wise results, so you get a result for a particular column, but scalar functions give you row-wise results. So you get results for each row in that column. So it's the same thing too. When you write subqueries and select, the value is displayed row-wise. So for example, if I write this query, select product, revenue, and this from other item table. So what is this one? This is the average revenue. So you might say, but this one is one value now since it's an aggregate function. Yes, you're going to get a single value. Yes. But what will now happen is for each product and its revenue, it will now repeat this average revenue in each row. So it just repeats the average revenue in each row. So the great thing here is, for example, let's say you now want to subtract, maybe you want to do some calculation, probably you want to subtract this average revenue from the revenue, then like you want to do X minus X pound, something like that, then it should be easy for you to do it in this case. So under subqueries and select, we still have something called correlated subquery. So, and in this case, this subquery uses values from the outer query. Okay, so so I forgot to mention that this subquery is called the inner query, while this one outside there in black is called the outer query. So you can see that I've used color to differentiate them. So this is also the outer query, and this is the inner query. All right, so we have an example here. So let's say that we need a table of water samples, analysis to be done to that water samples and the costs of such analysis. And we have two tables, okay? We have the water samples table, where we can get sample name, or probably an ID for the water sample, then the analysis type. But we have another table that contains the different types of analysis and its costs. Okay, so we now want to select cost from that analyst costing. Well, we now indicate that where the analysis type here equals to, sorry, where the analysis type in this analysis cost table equals analysis type in this water samples table. Just give me a minute. This should be WS. So where this analysis type, the analysis type from this table equals to the analysis type in this water samples table. Okay, so you what we now get is we get the sample name, the analysis type, then this we get the costs of each analysis type. Join it to this columns. So this is kind of replacing join. Just as we said, subqueries sometimes can be used as alternative for joins, because here we are considering two tables now, and we're already querying some content from this analysis cost table and joining it with the content from this water samples table. So that's an example of correlated subquery. So now let's talk about subqueries in from/join. I think that's the last one, okay? Now subqueries can be used in the from and join to create derived tables that can be queried again. So this is very useful when we want to use aggregated data along with long data. So remember that over here, we have this table, okay, that contains sample name, analysis type, and the cost. That's why the earlier state has cost. So, but let's say that I now want to calculate the total costs that is going to take me to analyze all the samples. Okay. So I have to calculate the sum of cost, but remember, you calculate your functions in the select statement. So this whole query that we had before, okay, will now be in the from statement, because this is now a table on its own, starting from this brackets to these brackets. So this is now a table on its own, and it has 3 columns: sample name, analysis type, and costs. Okay, so, but I want to add all the costs together. So this is now a new table. So when you are writing subqueries in from statement, it's important for you to put alias. So because you have to like give a name to this table, this derived table or intermediate table that you have formed. Okay, so also when you write subqueries under select too, it may be good to put the alias so that it doesn't display all this gibberish. Let me go back again. So you don't want it to display all this, so it will just display it as costs. Okay, so it makes the table simple. That's the function.
To ask, like, what do you mean we should add something? I want to know what you meant we should add.
Yeah, so I was saying that for when you write subqueries under from, you need to include the alias, because this alias now starts as the the table name, and can be used to reference columns from that table. Okay, remember from, you always write tables under from, right? From so table. So, but your table now is a subquery. So you need to give it an alias to identify this derived table. Okay, so in this example here, our derived table is called total costs. Okay, so even here I can put sum into brackets, total cost dot costs. Therefore, referencing it, I want the cost column in this total cost table. Okay, so that is the way to go about it, because it makes it easy to reference, because if you look here, we already have cost here from the analysis cost table. So we don't want to confuse ourselves. Which cost are we talking about? So in this case, the cost I'm talking about is the cost in the total cost table, which is the subquery that we have here. So do you have any question before we move to practice? So we have been able to cover, we have been able to talk about the different positions in which you can add your subqueries, and the reason why you are going to write subqueries in those clauses or statements.
Yes, sir. I want
Do
to
you
ask
have
a
a
question.
question? Yeah,
Yeah.
please do.
In your query, I want to know why there's an underscore. Like, what's the usefulness of the underscore?
It depends on how your columns are named. So, but most times we don't always want spaces in our columns. Okay, because if there's a space, for example, here, if I write ws dot sample and I leave space and I write name, based on what we learned yesterday, automatically MySQL will see that name as an alias for this ws dot sample. Because you can actually just use space and write the alias of a particular column. It's not compulsory that you always put this AS. Okay? So if there's space there, MySQL will see it as an alias. So it's best to use underscore or probably a dash or things like that.
Is
Or
the
you can
AS
use
like
camel case. Okay,
camel?
sorry, camel.
Is
Yes,
the AS
you know what
is the
camel
AS
case is. Okay,
no?
so camel case
Oh,
is this sample will be in small letter. Then okay, let me escape from here and show you this. So for example, if I want to write this in camel case, I just write it like this. So can you see this? So this is still very readable. Sample name. So the first part of the name will be in small letter. Then the next one will start with a capital letter, while the remaining alphabet will be in small letter. So it makes it still readable to the human eyes. So that's an example of a camel case. Okay, you wanted to ask a question.
the AS, is it also part of
Mhm.
the code, or is just an like a means to form an alias?
So it's both. It's part of the code and it's so you are just what that as means is you are assigning all these a particular name. Okay. So for example, now all these things here, I'm assigning them what? Costs. So it kind of like a way to assign names, temporary names to some part of the code, which in this case, the part of the code that we're assigning it to is that subquery that you can see there. So the as is a keyword. We call it a keyword. So and it's used for aliasing. It's used for aliasing tables or columns. So I don't know if that answers your question. And
Yes, I answered. Thank you, sir.
okay. All right. So if we have no further questions, we can move on now to MySQL. So as usual, we have some questions that we want to answer in order to be able to apply these things that we have talked about. So the first question is, so let us just go through our tables again, the tables that we have. So we have the product table, we have the orders table, customers table, order item table rather, and returns table. Okay, so these are the tables that we have. So remember that the products table contain information about the products for our for our e-commerce company. Then the orders, these are the different orders. So the customers that made the order, the dates, the status, and the payment method. Then the other items show details about the order. The product that was ordered, the quantity, unit price, and discounts that was offered. We have a column for customers, showing the customer ID and their details. And lastly, returns. Returns table captures why some products were returned. So you see the order that was returned, the return date, the reason, and how much was refunded. Yeah. So, like I said yesterday, you need to understand your data so that you see how you can use it to answer your business questions. Okay, so which products performed below average revenue? Which products performed below average revenue? So I'll be taking us sometimes to the queries that we wrote yesterday, so that we can make some comparisons. Okay. So normally, if I want to know the products that performed or the performance of a product, I want to examine product. Which table will I go to? Which table will I select from? I'll need your inputs, please. Which table will I select from? I need information about the products. So which table?
Product table.
Products table. Okay. So if you look at the products table, yeah, we have the product ID, the product name. Okay, great, great. We have the price, the cost price. We have the cost of making the products. So, but we can't get anything about revenue from here.
So I go to the orders. So customer. So I go to order item. So quantity times price will give you revenue. So I'm thinking order.
Great, yes, other items. So other items will be able to help us. And thankfully, the product ID is here. Okay, so we can get the product ID that has that have above average revenue. So yesterday I shared this formula: revenue equals to quantity times unit price times 1 minus the discount. So because some products are actually giving discounts, so yes, so you just have to remove the discounts from 100%. Okay, so this will help us to be able to calculate the revenue. So you are correct. So I can copy this, but I'll need this for revenue. That's part of what I'm going to select. So we are selecting from the other items, right? So we are selecting from And from that other item, we need the product ID because we want to identify the product. The question says which products. Okay, and this will serve as our revenue, right? Okay, so that will give us a revenue. So, but the aim is which products performed below average revenue. So we need the average. So that means we are supposed to filter, right? Because here we want to filter out those that perform below average. So if we want to filter, we can use the where clause to filter. Okay, so normally we are supposed to filter this revenue below average revenue. Average. Okay, so normally this is what we want to do, right? So now what is our revenue? This is the formula for our revenue. So copy this formula because you can't use the alias in that way. Then we need to calculate this average revenue. And that's where our subquery now comes in. So we need the average of these revenues. And I'm also still going to get this from the order ID table. Order I can beautify it using this. Okay, so this now stands for our average revenue. So as you can see here, these are our average revenue. So we're comparing the revenue of each product to the average revenue. So once it is less than the average revenue, then you can return it. So let's run this. So we see all the columns, all the products rather, that generated revenues that were below average. So you might wonder, what is the average revenue? So probably let's say we want a column beside here that shows the average revenue. Okay, so let me just copy this subquery that calculates the average revenue. So this time I will now come to the select statement and I'm going to have my subquery here. Don't forget to put comma here because we are including a new column. So now I have a subquery here that will give me my average revenue. So remember, when the subquery is under select, it returns scalar values. So I can alias this as average revenue. Let's run this. So you can see our average revenue is that average is given to each row. So that is how subquery works under select. All right, so we know that our average revenue is 828.84. So you notice that all the revenues here are lesser than that. All the revenues here are lesser than that, showing that we got the right outputs. Okay, so we might not be interested in this. We can take this out. But one might say, this is just the product ID. What about the product is that I want to get the name of the product. I want to get the name of this product that performed below average revenue. Okay, so if you want to do that, you also write that under your select statement because you need the product name. So let's come here. Now, where are we going to get the product name from? Which table? You can get it from the product table. This is the product name. Okay. Products table. and we're selecting products. Okay. So once select products name from the product table, did I close this? So I can label this as product name. So we can call this product name. Okay. So, but since we just need this product ID, we need the products for this product ID. We need to link this with that. So I can alias is my other items table as OI, standing for other items. Okay. So I can write a where plus here, where product ID, the product ID in this table is equal to the product ID in the OI table. Okay, so I want this product IDs here. I want to use this product IDs here to go and fetch the product names under the product table. So let's see whether that is going to be great. So that runs fine. So you can see we have been able to get the product name for this product ID and their revenue. So these are the products that performed below average revenue, below our average revenue. Do you have any questions here before I move further to the next question? Okay, so I guess that we are getting it. The next question that I want to find answer is, which products generated an average revenue of 3,000 and above? Which products generated an average revenue of 3,000 and above? So this sounds like this, because this is which products perform below average revenue. So it's still the same thing, but the only difference, okay, so let me just copy this. Copy this. Okay, we'll just tweak this a bit. So we are getting our products name because they say which products. So we need our products name from the product table. And since we're also talking about revenue, so we also still need the revenue. Okay, so but here they are saying which product generated an average revenue of 3,000. So that means they want us to calculate the average revenue that the products generated, each of the products generated on average. Then now compare to 3,000 and above. Okay, so that means here we have to calculate average revenue. Let me close this in the brackets and I put average revenue. All right. So remember that when you have an aggregate function rather with colons, you need a group by. And group by usually come after away. So group by. So what are we grouping by? We are grouping by the product ID. Product ID. So we are grouping by the product ID. Our condition is that this average revenue is greater than 3,000 and above. So we don't need the where clause. Rather, we have to use the having clause. So we don't need this where clause. Okay. So rather, what we need is the having clause. So the having clause says that average revenue, of course, you can use alias in under having, should be less than or equal to 3,000. So this average revenue that we calculated here should be less than or equals to 3,000. So let's run this query to see. Great. Okay, sorry, is it less than an average 3,000 and above? Oh, so it's greater than or equal to, right? Should be greater than or equal to. Yeah, so we have this 1, 2, 3, 4, 5, 6. So these are like our top performing products because it generates more than $3,000. Let me assume that the money is in dollars. Okay, so this gives insights on the types of products that are like our best performing products. So you notice that most of them are gadgets like cameras, tablets, and just a phone. So we have like 3 cameras here. We have 2 tablets and a phone. So it shows that the gadgets, probably our electronic gadgets, that aspect of our e-commerce store is the one generating the most revenue on an average. Okay, so of course these are some of the things that help to make decision about the business. So in this example, we are just having a subquery in the select statement. This subquery is helping us to fetch the product name. If you recall, yesterday we answered this question. Yesterday, let me take you guys back. We answered it yesterday. Something similar. Yeah, so which products generated an average revenue of 3,000 and above? So if we run this query, you notice that we just have the product ID and the average revenue. So, but with this subquery now, we're able to fetch the names of these products. So we're able to fetch the names of the products from the products table using this subquery in the select class. So that makes more sense because I can identify the products by the products ID. But with the name, it's better it's better. I'm able to quickly understand which products are the top performing products. So, do we have any question before we move to another question? Do you have any question on this? So I assume that we have no question. Then the next question is, who is customer ID 1000 and when did he order last? So I'm interested in a particular customer. I want to know who that customer is and when did he order last. So yeah, I can from the customer table, I can easily get who customer 1000 is. Is this person, Bernard Phillips? But from this table, I can't get when he ordered last. I can't get when he ordered last. But from the orders table, you can see the customer ID, and you can see the order dates. So from here, I can get the last time the person ordered. So here again, I have to work with 2 tables. Okay. So first of all, I can fetch his customer ID. I can fetch his first name. I can fetch his last name. From that customer's table. I just need to put a where clause that, okay, where the customer ID equals to 1,000. Okay. So you say I get this. I get Ronald Phillips as the person I'm interested in. Okay. So, but I need when he ordered last. And I can get that from the order table. So I just need to compare his customer ID to that of the order table to get when he ordered last. Then, since he could have placed several orders, he could have placed several orders here. So I can use the max function to get the latest date that he ordered. Okay, so I can use the max function. So let's go. So I need the last order date, right? So I need to select that orders table. And what do I want to select? I need the max of the order dates. I need the max of the order dates. And I want to group by the customer ID. Do I need to group by? No, I don't need to group by. Okay, so I think I can just use a where class. I can use a where class where this customer ID exists. Okay. So what that will do is that will give me the maximum order dates for this customer. So I want to name it last order date. So since I have my where clause here that's already identified the customer, I don't think I need this one anymore. I think I need that one. Okay, let's run this. Let's see. Okay. Oh, so he applied it to all the customers. So that means I still need to put this condition. I still need to put this condition here. So what he did was, from here, he selected the last order of. Okay, so I think I know what I can do so that I don't need to do this. Let me just link the two tables together, okay? So where customer ID equals the customer ID of the customer's table. Let me make this C. So this will now be equals to C dot customer ID. Let me do it that way. Okay, so that in case if I change this customer ID, okay, that will be the customer ID that will be searched for in this inner query. So this is an example again of a correlated query. Okay, so I think we should, yeah. So we get for that particular customer 1,000. So let's say I want another customer. I just simply have to change this here. Maybe I want 1,004. I hope there's something like that. Yeah. But and we can see that the date has changed from customer 1,000. This Scott's last order day was 29th of December 2024. And for our first customer, it was 8th of November 2024. Okay, so this is more flexible than coding it here, saying that customer ID should be equals to 1,000. Okay, so this is just another example again of a subquery used in the select statement. Okay, so now let's move on to the last example. Subquery in from. So for what reason are products returned most? Now we answered this question yesterday, actually. We used a method to answer the question. Let me take you guys back. So for what reason are products returned most? So what we did was we selected reason and we counted the number of rows, group by reason. So we counted the number of rows for each reason. So I will know how often that reason was repeated. Then we ordered by the count, so that in descending order, so that we get the most occurring reason first before others. And we now limited it to 1. So, but the issue here is, what if 2 or more reasons are the most occurring reasons? Okay, so that means they have the most occurring reasons. So what if 2 or more? So since I've limited my outputs to 1, I will only see one of those reasons. I might not be able to see the others. So this works best if there's only one reason. That is the most prominent reason. So, but in order to give chance for that case where 2 or more reasons could have the same number or could be the most occurring reasons, then we can use subqueries in from. Okay, so where do we get the reasons? We get the reason from returns table. We have the number of reasons here. Okay, so let me go back to my so let me just copy this table. Let me just copy this query and we adjust this. So this was a query we used yesterday. So we don't need all this now. I want to adjust this. So we are taking the reason. Okay. We are going to adjust this one later. So we want to get a table that will help us to arrange, or get the maximum the reason with the most occurring value. So the reason that occurs most. Let me write that. So from our form statements, we have select. And what do we want to select? We want to count. We want to get the ones that are the highest. Okay, so we want to get the count that is highest. All right. So, but we still need to calculate the count. We still need to calculate the count. So that means I will still have another subquery in this select column. To count all. That will be from the returns table. This will now serve as my count. Okay. for my returns table. So I need to group by. I need to group by the reason. I need to group by the reason. Group by reason. So what this does is it groups the data by reason and now counts the number of times that reason occurs. Okay, so now this max count is going to calculate the maximum from this table. All right, so I want to select the reason and I want to select, yes, I also want to count the number of times this reason appear, okay, from the returns table. So I'll go over it again so that seems, because I feel that you guys I have lost you guys here. So I just go over it again so that to avoid confusion. So the condition is that I want this count to be equal to this maximum count so that I know that, okay, this is the reason that has the maximum count. Okay, so I'm going to use having here. Having counts, this counts star, sorry, counts asterisk equal to this. Okay, so what have I done? So what I've done here is that I actually have two subqueries. Let me write them well so that, let me beautify this. Maybe it's going to write them better for me. Okay. So I have one subquery here. I'm selecting the maximum count from this table. So I have a subquery in the from table. What the subquery in the from table here is doing is it's counting it's just getting the count for each reason. That's what this is doing. It's getting the count for each reason. Okay, because it's grouping the table by reason, then getting the count, how many times that reason appears in the returns table. Okay, so it puts that under the column count. All right, so let me copy this and run this so you guys will see what this is doing. So you understand what I'm trying to say. So can you see this is count? So this is the number of times each of the reason appears. Okay, so that's what this subquery under from is doing. Remember, subqueries always start from the innermost query, which in this case is this one, in this from statement here. Then, when it has gotten this column, what this first outer query is now doing is to calculate the maximum from this whole table, from this whole column rather. It calculates the maximum. So which in this case, the maximum is 371. So max count will now be 371. So that can now be used to compare the count for each reason. So what this having is now doing is it compares the count for each reason with the maximum to see which ones have the maximum count. So what it's going to do is that it's going to check this 235 is equals to 371. No, that one is gone. 371 is equals to 371. Yes. So that one is filtered out. 241 is equals to 371. No, like that. So at the end of the day, you have only this one that has 371. But I don't want just the counts. I want the reason for that count. So that means I have to group by. Okay, I have to group by, and group by always comes before average. So I'm going to bring my group by in. Group by the reason. Okay, group by the reason. So let me run this now. Okay, there's an error. Unknown count. This one. This one should even be that. This should be like table or something. It should just be like table. No, let me not use table. Let me just use T. Because it's in the from statement, so I can just use an alias for it. So the problem, the error here was that this column that is being, this aggregate that is being calculated from the reasons here, I didn't give it a name, count. I am not asking it to calculate the maximum count. So it does not know what count stands for. But now that I've named it count, then it can work here. So let's run this. Great. So we have defective equals to 371. That is the reason that the reason for products being returned most. Okay, so if we compare it with what we did yesterday, this still gave us the same answers. Let me run this. Can you see? Defective 371. So, but for example, I said that what if another reason also had 371? You won't see that one because you limited it to 2. So you only see one, this one that is showing. But in this case, even if there are more than one maximum value, it is going to identify them because this halving is checking the counts for each reason and comparing it with the maximum count. Okay, so because of that comparison, anyone that is equal to that maximum count will be displayed. So if there are 3, 4 reasons that is the most occurring reason, they will all be displayed. All right. So I don't know if you have any question. This.
Yes, sir, I understand.
Okay, that's great. That's good. I was actually thinking that I had actually caused a lot of misunderstanding with it, especially with this last one. But thankfully, you get it, you understand it. Thank you, Adeyemi. I saw your thumbs up. It shows that you understand. Thank you. So I'll be handing over to our chief host, Mr. Said. Mr. Said, are you there?
Yeah. Thank you so much for this wonderful presentation. We really appreciate you and we really appreciate your knowledge. Thank you so much, sir. So
Thank you,
for
Mr.
our
Said.
participants, you're welcome, sir. For our participants, if you have any question, don't hesitate to just as an ask, because that's why we are here. We are here to learn, irrespective of any gray area that you might be not clear with, just as an endeavor to ask in order to clarify, because as having that ability or that courage to ask of what is unclear to you, you've gained the knowledge. So that's all about that. Thank you so much, and we'll be great to have Sir Isaiah tomorrow to complete another part of our Launchpad. Thank you so much for you guys attending tonight's class. See you all tomorrow.